The cosmos looks like a living creature. Galaxies are strung together in a vast, shimmering web, connected by invisible threads of force in a pattern that mirrors a brain or a root system. This is the profound mystery we are exploring today, why the universe appears structured like a living network. By the end of this journey, you will possess a new framework for reality itself, one where you are not just in the universe, but are a conscious thread within its fabric. We will uncover how the largest structures in existence share a hidden blueprint with the smallest parts of nature, and ask if the empty space between stars is truly empty at all. What does it mean to see yourself as part of this cosmic tapestry? Look up at the night sky, and you might see a scattering of stars, but that view is a cosmic illusion, a trick of perspective. Step back far enough, and the universe reveals its true architecture. It is not a random sprinkling of lights. Instead, galaxies are gathered into immense, delicate threads. They form a tapestry of shining islands along vast, invisible highways, separated by unimaginably empty chasms. This is the cosmic web, the skeleton of everything we see. It is the largest pattern in all of existence. The first time astronomers began to map this structure in earnest, they were stunned. The data from massive galaxy surveys did not show a uniform fog or a simple cluster. It painted a picture of intricate connection, a luminous network stretching across billions of light years. If you could see it all at once, it would look less like a star field and more like the branching neurons of a brain or the underground root system of a forest. This is not a metaphor for artistic effect. It is the literal, observed structure of our cosmos. But how did this breathtaking order arise from the formless fire of the Big Bang? The answer lies in an unseen architect. In the early universe, tiny ripples in density were imprinted upon the fabric of space-time. These ripples were seeds. And they were given immense gravitational weight by something we cannot see, dark matter. Think of dark matter as the framework, the invisible skeleton. Its gravity acted like a cosmic glue pulling ordinary matter, the gas that would become stars and galaxies, into its embrace. Over billions of years, this process sculpted the universe. The densest knots of this dark matter scaffolding became the great clusters of galaxies. The strands connecting them became the filaments we now observe. And the empty regions, the voids, are the spaces in between where gravity won a lesser pull. So we have a map, a universe structured as a web. But this discovery presents us with a mystery far deeper than its origin. The pattern itself feels familiar. It echoes designs we see in living systems, in the branching of trees, the flow of rivers, the connections in a living brain. The cosmic web is a physical structure born of gravity and dark matter, yet its form whispers of a principle that seems to transcend physics alone. Is this magnificent architecture just a happy accident of cosmic mechanics, or is it a clue, a signature of something more fundamental at work in the heart of reality? This cosmic web is not an isolated design. Its pattern emerges elsewhere in the universe, not in deep space, but right here on our own planet. Look at a photo of a river delta from space. Then look at a scan of the human circulatory system. Then look at the branching veins of a leaf. The resemblance is not a coincidence. All of these are examples of fractals, a mathematical concept that describes shapes which look roughly the same no matter how much you zoom in or out. A tiny twig mirrors the structure of a large branch, which mirrors the entire tree. A small crack in the mud has the same jagged character as a vast canyon. This is self-similarity, a signature of a pattern that builds upon itself. The visionary mathematician Benoit Mandelbrot gave this phenomenon its name. He saw these repeating patterns everywhere, from the erratic fluctuations of the stock market to the length of a coastline, which becomes longer the more closely you measure its inlets and coves. Mandelbrot boldly speculated that the universe itself might be fractal in its very architecture. For decades, this was a beautiful, poetic idea. Then we began to map the cosmos. When scientists analyzed the distribution of galaxies, they found something astonishing. The way galaxies cluster into groups, those groups into larger clusters, and those clusters into the immense filaments of the web, exhibits a statistical self-similarity. It is not a perfect, exact fractal like a drawn snowflake, but the underlying pattern, the scaling law, is eerily similar. What does this mean? It suggests a universal language. The same mathematical rules that describe how a fern unfurls, how a lung maximizes its surface area to breathe, and how a lightning bolt finds its path, also seem to guide the gravitational collapse of matter on the largest scales imaginable. This is a profound blurring of lines. We are used to thinking of the living world as one category, governed by biology, and the inanimate cosmos as another, governed by physics. Yet here they are, whispering the same mathematical secret. It implies that growth, connection, and the efficient filling of space follow a kind of cosmic logic, a preferred blueprint that reality tends to follow, whether it is building a network of blood vessels or a network of galaxies. This fractal parallel is our first major clue that the structure of the universe is not merely random, but echoes a deep, foundational pattern found throughout nature. And if fractals connect the cosmos to life, our next parallel ventures into an even more intimate territory, the very seat of consciousness itself. This fractal pattern is a clue, but it is only the shape of the mystery. To understand its function, we must look at the principle of connection itself. Every complex system, whether natural or human-made, is built upon a simple blueprint, nodes and the links between them. In the cosmic web, galaxies are the luminous nodes. The links are the invisible threads of gravity that bind them across the void, along filaments of dark matter. In your own body, cells are the nodes. They are linked by a constant flow of chemical signals and electrical impulses. This is the architecture of a network, and it is everywhere. The internet is a network of computers and data cables. A forest is a network of trees connected by fungal filaments in the soil. Even our social circles form a network of people and relationships. Scientists use a field called network theory to study these connections, and what they find is astonishingly consistent. Certain types of networks keep appearing because they are simply the most efficient way to organize a complex system. One of the most powerful network designs is called the small world property. You have likely experienced this. It is the idea of 6 degrees of separation, where any two people on Earth might be connected through just a handful of mutual acquaintances. This structure allows for incredibly fast communication or influence transfer across vast distances with very few steps. Your brain is wired this way. The global air travel system is built this way, and when researchers apply network theory to the map of the cosmic web, they find it there too. Through the gravitational links along filaments, a galaxy in one cluster could theoretically influence a galaxy in a faraway cluster through a surprisingly short chain of interactions. The universe in its vast architecture appears to be wired for efficient connection. This is a staggering implication. The small world structure in your brain allows a thought to form by connecting distant neurons quickly. The same structure in the cosmic web suggests that influence, whether it is gravitational or something we do not yet understand, can also propagate efficiently across the cosmos. It hints that efficient communication might be a universal imperative, a fundamental principle that shapes reality from the scale of cells to the scale of superclusters. The universe is not just patterned like a network, it operates like one. And if both the cosmos and living systems are built for connection, it forces us to ask a much more profound question. What if this network is not just a structure but a kind of system? What if the universe itself possesses properties we typically associate with a living, dynamic entity? The visible universe floats upon a deeper, hidden sea. For every galaxy we see shining, there is an immense, invisible presence holding it in place. This is dark matter, the silent architect of the cosmic web, and it makes up not a small fraction, but a staggering 85% of all the matter in the cosmos. We cannot see it, touch it, or detect it with any telescope that observes light. Yet we know it is there because of its undeniable gravitational pull, the way it bends the paths of light from distant galaxies and dictates the very rotation of stars within them. Without this unseen substance, the magnificent structure we call home would simply not exist. It acts as the universe's invisible skeleton, a framework of gravitational wells that guided the flow of normal matter in the aftermath of the Big Bang. Picture a vast, intricate root system hidden beneath a forest. The trees you see, the galaxies, are only possible because of the network below, drawing in nutrients and providing stability. Dark matter is that cosmic root system. It formed the gravitational valleys where ordinary gas could pool, cool, and eventually ignite into the first stars, seeding the galaxies that now trace out the luminous threads of the web. This reveals a profound duality in the nature of reality. The glittering tapestry of stars and galaxies we admire is merely the decoration, the visible growth upon a much larger, hidden structure. It echoes a principle we see throughout nature. A towering redwood tree is a visible marvel, but its life depends entirely on a vast, unseen network of fungal filaments in the soil, exchanging nutrients and information between trees in a silent, collaborative web. Our own bodies are visible organisms, yet they are sustained by an entire universe of gut microbes and complex chemical signaling pathways we never perceive. In each case, the visible entity is just the tip of an iceberg, supported by and inseparable from a deeper, interconnected system. The cosmic web, in its full truth, is not just the shining galaxies. It is the galaxies plus the dark matter filaments that connect them, the invisible circulatory system through which the gravity that shapes all things flows. This hidden architecture raises a tantalizing possibility. If the universe's structure depends so completely on something we cannot see, what other unseen forces or layers of connection might be at work, weaving the fabric of reality in ways we have only begun to glimpse? The universe is not a sculpture, fixed and unchanging. It is a conversation within every living creature, from the smallest cell to the most complex ecosystem. There exists a constant, whispering dialogue known as a feedback loop. It is a simple but profound process where the output of a system circles back to influence its own future input. Your body maintains its temperature this way. When you get cold, you shiver to generate heat, and once warm, the shivering stops. This self-regulation is a fundamental signature of life. Now, look out to the cosmos. That same principle of feedback is written across the history of creation itself. It begins with the very first stars, colossal behemoths known as population 3 stars. These pioneers were made almost entirely of hydrogen and helium, the raw elements forged in the Big Bang. They lived fast and died young, exploding in titanic supernova. That violent end was not a conclusion but a crucial input. Those explosions blasted space with newly forged heavy elements, carbon, oxygen, iron, the very building blocks of planets and life. This seeded the cosmic clouds that would collapse into the next generation of stars, now richer in complexity. The output of the first stars directly changed the conditions for all stars that followed. This is a cosmic feedback loop of creation, a cycle of death and rebirth on a galactic scale. We see this self-organizing principle everywhere we look. When two galaxies slowly merge in a gravitational dance, the collision compresses vast clouds of gas, triggering a fireworks display of new star formation. Those new stars, in turn, change the gravitational and chemical landscape of the galaxy, influencing how it will interact with its neighbors in the future. From simple rules of gravity and physics, immense complexity emerges, organizes, and evolves. This capacity for dynamic, iterative development is what separates a living forest from a static crystal. It is a process, not just a state of being, and the universe is clearly engaged in this process. It is not sitting still. It is talking to itself, using the echoes of stellar explosions and the gentle pull of gravity as its language, constantly refining and complexifying its own structure over billions of years. If the cosmos shares the shape of a network and the operational logic of feedback, we are left standing before a threshold, peering into a possibility that redefines everything. But if the cosmos operates through feedback and hidden connections, where does that fundamental link originate? To find it, we must journey to the very smallest scales of reality, into the quantum realm. Here we encounter a phenomenon so strange it baffled even Einstein, who famously called it spooky action at a distance. This is quantum entanglement. Imagine two particles born from the same event, sent flying to opposite sides of the galaxy. According to quantum physics, these particles are not independent. They remain mysteriously linked, a single connected system. If you measure a property of one, like its spin, the other particle instantly assumes a corresponding state, no matter the vast distance separating them. This connection appears to happen faster than light, a notion that challenges our classical understanding of cause and effect. It is as if the universe, at its most fundamental level, refuses to be divided. This profound interconnectedness has led some of the most brilliant theoretical physicists to a breathtaking speculation. Could these spooky quantum links be the basic stitches weaving the fabric of spacetime itself? Figures like Juan Maldacena and Leonard Susskind have explored a radical idea known as the ER equals EPR conjecture. In simplified terms, it proposes a deep equivalence. The phenomenon of quantum entanglement, the EPR part, might be geometrically the same as the existence of tiny wormholes or Einstein-Rosen bridges, the ER part connecting regions of space. In this view, every entangled pair of particles could be thought of as connected by an unimaginably tiny bridge through the fabric of reality. This is not suggesting we could travel through them, but rather that the geometry of space, its very connectedness, emerges from a vast, underlying network of quantum entanglement. Think of it this way: in a living brain, individual neurons are not conscious. Consciousness emerges from the incredibly dense pattern of connections between them, the synapses firing in a vast, dynamic network. What if the universe operates on a similar principle? What if each quantum entanglement is like a single, fundamental synapse, a basic unit of connection, and the spacetime we experience, with its galaxies strung along filaments, is the emergent large-scale structure of this cosmic neural network? This idea posits that the network-like architecture we see in the cosmic web is not an accident of gravity alone. It might be a physical manifestation, a geometric echo, of a universe that is fundamentally woven together by quantum information. The filaments connecting galaxy clusters could be seen as the large-scale shadows of these primordial quantum threads. It is a highly speculative yet profoundly elegant vision, one that dares to weave a single narrative from the quantum realm to the cosmic web. It suggests the universe is not merely structured like a network, but that it is, in its most basic essence, a network, a living tapestry of information where the very small and the very large are inseparable parts of a single, conscious-seeming whole. A network is not defined by its shape alone, but by the life moving through it. In a forest, it is nutrients and water flowing through fungal roots. In your body, it is blood and electrical signals. For the cosmic web to feel truly alive, we must ask what flows through its filaments. The answer is a river of creation itself. While the dark matter skeleton remains still and invisible, the threads of ordinary matter that trace its form are highways for a vital cosmic traffic. Vast rivers of cold, primordial gas, left over from the birth of the universe, stream along these filaments for billions of light years. Their destination is the hungry galaxies waiting at the intersections. This process has a name: cold stream accretion. Think of it as the cosmic web's circulatory system, delivering the raw hydrogen fuel that galaxies need to forge new stars. Without this constant inflow, galaxies would starve, their stellar fires flickering out. This is not a static sculpture, it is a dynamic metabolism. The universe is actively feeding its largest structures, sustaining them across cosmic time. But the flow is not just matter, it is also energy. At the heart of nearly every galaxy sits a supermassive black hole, a gravitational titan millions to billions of times the mass of our Sun. These are not merely passive drains. When they actively feed on surrounding gas, they become the most powerful engines in existence. The infalling matter swirls into a blazing disk, and the black hole can eject colossal jets of energy and particles, shooting out along its poles for thousands of light years. This released energy is so immense it can heat the surrounding galactic gas, preventing it from cooling and collapsing into new stars. In this way, a supermassive black hole acts as a cosmic regulator, a feedback thermostat for its entire galaxy. It is a stunning realization that an object so dense not even light can escape it also serves as a life-giving, or life-limiting, heart for its galactic home. And this energy circulates further. Cosmic rays, particles accelerated to nearly the speed of light by stellar explosions and black holes, zip through the voids. Gravitational waves, ripples in spacetime from cataclysmic events, wash through everything. The universe is awash in currents, a symphony of transformation where matter becomes energy, and energy shapes matter. This constant circulation and conversion is what maintains the cosmic structure, preventing it from either collapsing into a dense knot or dissipating into a thin, formless haze. It is a dynamic equilibrium, a balance of forces and flows that is the hallmark of any complex, sustained system. From the gas flowing into a galaxy to the energy blasting back out, we see a cosmic process of breath, an inhalation and exhalation on a scale so vast it defies human comprehension. If this is the metabolism of the cosmos, then what, we must wonder, could be its mind? Life does not arrive fully formed, it unfolds. A single cell divides, adapts, and over eons gives rise to the breathtaking diversity of the forest and the ocean. This story of change over deep time is not unique to biology. The universe itself has a biography, a grand narrative of evolution written not in genes, but in gravity, light, and the slow, patient work of cosmic expansion. The galaxies we see today are not the galaxies of the distant past. They have histories. Billions of years ago, they were smaller, bluer, and more chaotic, furiously forging their first generations of stars from pristine gas. Over time, they have grown, changed color as their stellar populations aged, and often merged with their neighbors in majestic, slow-motion collisions that reshape entire constellations. A large spiral galaxy like our Milky Way is likely the product of numerous such mergers, a cosmic amalgamation of smaller systems over time. This is not a random drift, it is a directed transformation. Gravity acts as the great sculptor, pulling matter into denser configurations, encouraging galaxies to cluster, and weaving the diffuse clouds of the early universe into the sharp, defined filaments of the modern cosmic web. We can watch this evolution in snapshots by looking deeper into space, and thus further back in time. The further out we look, the younger and more disorganized the universe appears, with galaxies more isolated and the web-like structure far fainter. more like a faint watermark on cosmic paper. Today, the web is stark and clear, a testament to billions of years of gravitational refinement. So while this is not Darwinian evolution with competition and reproduction, it is unequivocally a form of structural evolution. The universe's architecture adapts and complexifies over time based on the initial conditions set at the Big Bang and the unchangeable constants of physics, like the strength of gravity. These laws are the universe's rulebook, and within them, the cosmos explores every possible arrangement, settling into the most stable, efficient configurations, much like a river carving the path of least resistance through a landscape, or a species adapting to fill an ecological niche. This shared narrative is profound. Both life and the cosmos tell a story of becoming. They are not static paintings but ongoing processes, dynamic systems with a past, a present, and a future state. Recognizing this transforms our place within it. We are not living on a fixed stage, but are participants in a grand, unfolding story of cosmic development, one where the very stage is growing, connecting, and evolving alongside us. Our existence here is the universe's most curious observation of itself. We are stardust that has awoken, atoms arranged into a form complex enough to look back at the cosmic web and wonder about its nature. This very act of observation is not a trivial side effect. It is the heart of a profound philosophical and scientific puzzle known as the Anthropic Principle. In its simplest form, it states that the universe we observe must be compatible with the existence of observers. At first glance, this seems obvious, even tautological. But look deeper. The fundamental constants of nature, the strength of gravity, the force that binds atoms, the mass of an electron, appear to be exquisitely, almost miraculously fine-tuned. If gravity were even slightly stronger, the universe would have collapsed back on itself instantly after the Big Bang. If it were slightly weaker, no stars or galaxies would have ever formed. The same is true for a dozen other constants, a delicate balance that seems precisely calibrated to allow for the emergence of stars, planets, and ultimately, life. The odds of this happening by random chance are astronomically small. So why is our universe so hospitable? One answer is the multiverse, a sea of countless universes, each with different physical laws, and we simply find ourselves in the one rare bubble where conditions allowed us to be here. But another interpretation is far more intimate and challenging. It is called the Participatory Anthropic Principle, inspired by the work of physicist John Archibald Wheeler. He proposed that observers are necessary to bring the universe into being. In the strange world of quantum mechanics, a particle exists in a haze of probabilities until it is measured, at which point it settles into a definite state. Wheeler speculated that in some way, on a cosmic scale, the universe requires a conscious observer to crystallize from possibility into concrete reality. This does not mean we create stars with our minds, but rather that the universe and the observer are a single, inseparable system. The network is not complete without the nodes that perceive it. This idea places us in a startling new role. We are not passive tourists drifting on a cosmic raft that happen to float by. We are active, integral components of the cosmic web itself. Each conscious mind is a node within the network, a point where the universe becomes self-aware, where it reflects upon its own structure and beauty. Our quest for understanding, our science, our art, our sheer wonder at the night sky, could be seen as the network processing information about itself, evolving not just in structure but in meaning. This adds a breathtaking layer of purpose to our existence. If the universe tends toward connection, complexity, and perhaps even a form of self-awareness, then our consciousness is not an accidental glitch. It might be a feature, a flowering of the cosmic network's deepest potential. We are the universe's way of knowing itself, participants in a grand dialogue that began with a quantum fluctuation and now continues within the neural networks of our own brains. This shifts the entire paradigm from a universe we are merely in to a universe we are fundamentally of. Light itself is a time machine. Every photon that reaches our telescopes carries a story from a distant past, a fossilized snapshot of the universe at a specific moment in its long life. To understand how the cosmic web came to be, we must become cosmic archaeologists, sifting through this ancient light to reconstruct a history written across billions of years. Our most profound relic is the cosmic microwave background, a faint glow that permeates all of space. This is the afterglow of the Big Bang, cooled and stretched by cosmic expansion over 13.8 billion years until it became a whisper in the microwave part of the spectrum. But it is not perfectly uniform. When we map it with exquisite precision, as satellites like Planck have done, we see a mottled pattern of tiny temperature differences, hotter spots and colder spots. These fluctuations are not random noise. They are the primordial seeds, the gravitational blueprints for everything that followed. Those slightly denser patches, imprinted when the universe was a mere 380,000 years old, held a tiny bit more gravitational pull. Over eons, they drew in more and more dark matter and gas, growing into the first clumps that would become galaxy clusters and the filaments that connect them. The entire majestic architecture of the modern cosmic web is traced back to this subtle fingerprint in the newborn cosmos. But we do not have to stop at the beginning. The universe's history is layered in light, and we can read each chapter by looking out to different distances. This is where Redshift becomes our most vital tool. As the universe expands, light from distant galaxies is stretched to longer, redder wavelengths. The greater the redshift, the farther away the galaxy, and thus the further back in time we are seeing. By conducting massive surveys that map the three-dimensional positions of millions of galaxies at different redshifts, cosmologists can effectively create a flipbook of cosmic evolution. We can see the universe in its adolescence when galaxies were closer together and the web was a faint, ghostly suggestion. We can watch as gravity does its patient work, pulling matter into the densest regions, sharpening the filaments and emptying the void. Each map is a frame in the movie of the cosmos growing up. This empirical timeline is our strongest evidence that the universe's structure has a developmental story. It did not spring forth fully formed, it evolved. From that nearly smooth, hot soup revealed by the cosmic microwave background, we see a clear progression toward the intricate, connected network we inhabit today. This detective work confirms that the cosmic web is not a static stage set. It is a dynamic, historical entity with a past that we can observe and a future we can project. We are not just looking at a beautiful pattern, we are reading its biography, written in the language of light and shadow across the expanse of time. And if we can read its past, what might its future chapters hold? A truly robust system can withstand a shock. A forest fire may claim a grove of trees, but the fungal network in the soil survives, ready to nurture new growth. A single memory pathway in your brain can fade, yet the memory itself often persists through alternative connections. This principle is called redundancy, and it is the hidden source of resilience in every complex network we know. It is the existence of multiple pathways to the same goal, ensuring that the failure of one component does not mean the collapse of the entire system. And when we turn our gaze upward, we find this same fail-safe design etched into the cosmos. The cosmic web is not a delicate crystal lattice, shattering at the slightest touch. It is a distributed, deeply redundant architecture built to endure. Consider the violence contained within a single thread of this web. A massive star, after millions of years of stable fusion, can end its life in a cataclysm called a supernova. This explosion is unimaginably powerful, capable of sterilizing any planetary system within its reach and blasting its constituent elements back into the void. It is a local apocalypse, yet from the perspective of the galaxy that hosts it, and certainly from the vantage of the filament that galaxy calls home, this event is a minor adjustment. The supernova enriches the surrounding gas with heavy elements, potentially triggering new star formation elsewhere. The galaxy's overall structure, held firm by the collective gravity of billions of other stars and its vast halo of dark matter, continues unperturbed. The network absorbs the disturbance because the function of star formation and galactic evolution is not entrusted to any single star or even a single nebula. It is a distributed process happening in countless locations simultaneously along the vast length of a filament. This is the first layer of cosmic redundancy, the resilience of scale. But the true bedrock of the web's stability lies in its invisible foundation. Remember the dark matter skeleton, the framework that dictates where luminous matter will flow. This framework is incredibly robust. While visible matter can be blasted about by supernova, shredded in galactic collisions, or consumed by black holes, the dark matter halo that defines a galaxy's gravitational presence simply passes through these events largely undisturbed. It provides a persistent, unchanging anchor. Think of it like the deep root system of an ancient forest. A storm may break branches and strip leaves, the visible, living matter, but the roots hold firm, ensuring the forest structure and its capacity for regrowth remain intact. The dark matter is the cosmic root system. This creates a profound separation between the dynamic, ever-changing visible universe and the stable, enduring gravitational scaffold. One dances upon the other. This architectural redundancy means the cosmic web possesses a kind of immortality at the largest scales. Individual stars are born and die. Galaxies merge and transform, but the large-scale pattern of filaments and nodes governed by that dark matter framework evolves with a glacial, unwavering patience. It is a system designed for the long haul, capable of integrating local chaos into its grand, orderly progression. This mirroring of biological resilience is not a trivial observation. It suggests that the principles which allow a living system to heal, to adapt, and to persist are not unique to the chemistry of carbon-based life. They appear to be universal principles of organization, emergent properties of any sufficiently complex, interconnected network. The universe has built in its own backup systems, ensuring that the story it is telling, the magnificent unfolding of structure from simplicity, continues unabated, no matter what local dramas play out within its shining threads. The most resilient systems often hide their true nature behind a simpler facade. To understand the universe's deepest secrets, we might need to let go of a dimension altogether. This is the staggering proposition of the holographic principle, a theory born at the fiery intersection of quantum mechanics and gravity. It suggests that everything we perceive in our three-dimensional world, every galaxy, every filament of the cosmic web, every atom in your body, might be a projection. A cosmic illusion, like a hologram on a credit card. But instead of a flat sticker creating the illusion of depth, the theory proposes that all the information describing a three-dimensional volume of space is actually encoded on a two-dimensional surface that surrounds it. Think of the universe as a sphere. The holographic principle posits that the complete description of everything inside that sphere, every event, every particle, is not stored within the volume itself, but is painted like a cosmic tattoo onto the sphere's outer skin, its boundary. The three-dimensional reality we experience would then be a kind of grand projection from that two-dimensional surface of information. This idea did not emerge from pure philosophy. It arose from the study of black holes and a profound puzzle about information. When matter falls into a black hole, it vanishes from our universe, seemingly taking all information about its properties with it. This violates a core tenet of quantum mechanics, which states that information can never be truly destroyed. The physicist Leonard Susskind, building on earlier work, found a potential solution. He realized that all the information about the matter that fell in could be entirely encoded on the black hole's event horizon, its two-dimensional point of no return. The three-dimensional interior, the black hole itself, could be a projection from that encoded data on its surface. This radical notion was later extended by others, like Juan Maldaisner, to the universe as a whole. If true, the implications for our cosmic network are nothing short of revolutionary. The vast three-dimensional tapestry of the cosmic web, with its filaments and nodes stretching across billions of light-years, might not be the fundamental reality. It could be a magnificent projection, a three-dimensional read out of information that is stored on a distant, two-dimensional boundary at the edge of space and time. This transforms our understanding of the network from a physical structure of matter and energy into an informational structure. The filaments are not just rivers of gas, they are flows of data. The nodes are not just galaxies, they are processing centers in a cosmic computation. The universe's appearance as a living, connected network could then be seen as the natural output of this fundamental information processing happening at the most basic level of reality. Physics and information theory become inseparable. In this view, the universe is not just like a computer, it might literally be one, with the laws of physics acting as its operating code, and the holographic boundary serving as its ultimate hard drive. This is perhaps the most extreme expression of the network analogy, where the cosmos is not merely structured as a network, but is the projected image of a deeper, informational network we cannot yet see. It suggests that the search for the source of cosmic order may not lead us to a place, but to a process, an eternal translation of data from a flat, silent surface into the rich, dimensional world we call home. The resilience of a holographic universe points to a reality built from information, but information alone is not experience. There is a final, breathtaking leap the network analogy invites us to consider, one that ventures to the very edge of science and philosophy. If the cosmos truly mirrors a neural network in its structure and dynamics, could it also share a neural network's most mysterious property? Could the universe, in some vast, slow, and utterly alien way, be conscious? This idea is known as Panpsychism, from the Greek words for all and soul, though modern versions frame it less mystically. It proposes that some form of mind or subjective experience is not a rare product of biological brains, but a fundamental feature of reality itself, as intrinsic to the fabric of the cosmos as space, time, or mass. In this view, the particles that make up stars and galaxies possess not just physical properties like spin and charge, but an infinitesimal spark of raw experience, a kind of proto-consciousness. When these particles combine into systems of immense complexity and connection, like a human brain or perhaps the cosmic web itself, that basic experience could coalesce into a higher, more integrated form of awareness. It is a radical thought, one that flips our conventional story on its head. We typically assume that consciousness emerged very late in cosmic history, a fragile flame lit only in the warm, wet tissue of evolved brains on a handful of planets. Panpsychism suggests the flame was always there, smoldering in the embers of every atom, waiting for the right network to fan it into a blaze of self-reflection. This is not a testable scientific hypothesis in the traditional sense, and it is crucial to state that clearly. We have no instrument to measure cosmic thought, no experiment to detect a galaxy's dream. But as a philosophical endpoint of the network analogy, it is profoundly challenging. It forces us to ask what consciousness really is. Is it merely the byproduct of a specific biological computer made of meat? Or could it be an emergent property of any sufficiently complex, interconnected system? We see complexity and connection in the human brain, and we know it gives rise to mind. We see staggering complexity and connection in the cosmic web, operating over scales and time frames we can scarcely comprehend. The structure is there, the feedback loops are there, The dynamic, self-organizing flow of information is there. While we cannot say it gives rise to a mind like ours, the pattern compels a humbling question. Are we looking at a different kind of neurological architecture? Imagine the cosmic web not as a dead scaffold, but as a sleeping nervous system. The galaxies are its firing neurons. The filaments are its axons and dendrites, conducting gravitational influences and flows of matter at the speed of light. The dark matter framework is its silent glial cells, providing structure and support. A single human thought arises from the synchronized firing of billions of neurons. What kind of thought, what kind of experience could arise from the synchronized evolution of hundreds of billions of galaxies over billions of years? It would not be a thought of words or images. It would be a thought of gravitational tides and stellar births, a slow, deep meditation on structure and connection itself. This perspective does not diminish our own consciousness. It elevates our place within the whole. If some form of mind is fundamental, then our own awareness is not an isolated accident. It is the universe becoming locally aware of itself, a node in the network waking up and looking around at the other nodes, sensing the threads that bind it all together. We are not just studying the cosmic web, we are the web studying itself. This speculative leap ultimately serves a profound purpose. It stretches the boundaries of our imagination to fit the data. The universe looks like a network, operates like a network, and evolves like a network. To wonder if it feels like something to be that network is perhaps the most natural and the most haunting question of all. The leap from cosmic consciousness to its physical origin seems impossible to bridge, yet the secret lies in a single, elegant mathematical truth. How can the simple give birth to the complex? This is the study of emergence, the phenomenon where local interactions between basic parts spontaneously generate global order, a property not present in any individual piece. It is the universe's most powerful creative principle, and it is written into the fabric of everything, from the swirl of a flock of birds to the architecture of the cosmos itself. Consider the cosmic web. Its breathtaking complexity began with two profoundly simple ingredients: the law of universal gravitation and those tiny quantum ripples in the density of the early universe. Gravity is a humble rule. It says every piece of matter attracts every other piece. Acting over billions of years on those microscopic seeds, this single force orchestrated the collapse of dark matter into filaments, the pooling of gas into galaxies, and the weaving of the entire luminous tapestry. No external hand guided each star into place. The grand design emerged from the collective obedience of every particle to one fundamental law. We see this same creative magic in the living world. A single cell follows simple chemical rules about when to divide and how to signal its neighbors. From those local interactions, the magnificent, organized form of a complex organism emerges with specialized organs and intricate systems. An ant colony operates on a handful of basic behavioral triggers for each ant, yet the colony as a whole displays sophisticated problem-solving, architecture, and resilience that no single ant possesses. The intelligence of the hive is an emergent property. To understand this process, scientists use powerful mathematical tools that simulate how emergence works. One classic example is cellular automata, like the famous Game of Life created by John Conway. Imagine a vast grid of squares, each one either on or off. You start with a random pattern, then apply just a few simple rules that determine whether a square turns on or off based on the states of its immediate neighbors. From these minimal local rules, astonishingly complex, lifelike patterns emerge on the grid, gliders that seem to move, pulsars that oscillate, and structures that grow and replicate. The global complexity was never programmed in. It arose spontaneously from the bottom up. Similarly, agent-based models simulate how individual agents, following simple programmed instructions, can generate flocking birds, traffic patterns, or even economic trends. These models are digital laboratories for emergence, showing us that intricate, intelligent-seeming order does not require a top-down designer. It is the natural, almost inevitable consequence of many simple parts interacting within a framework of rules. This understanding is a powerful demystifying force. The network-like appearance of the universe, with its echoes of living systems, no longer seems to demand a mystical or supernatural explanation. Instead, it points to a deep, unifying logic woven into reality. Breathtaking complexity can be, and perhaps always is, the natural output of basic ingredients and simple, consistent rules playing out on a grand scale. The cosmic web and the neural network in your brain are both magnificent examples of emergent order, arising from different substrates but following the same fundamental mathematical melody. This realization does not diminish the wonder, it deepens it. It means the universe possesses an innate creativity, a capacity to generate beauty and structure from simplicity, all on its own. And if emergence is the engine of cosmic creation, then the next logical question is breathtaking. What other levels of order might be emerging right now within the network that we have not yet learned to see? A forest does not burn energy like a mouse. This is a fundamental truth of biology, captured by a principle known as Kleber's law. It states that an animal's metabolic rate, the speed of its internal engine, scales with its body mass in a precise, non-linear way. A creature that is 100 times heavier than another does not need 100 times more energy to live. It typically needs only about 32 times more. This is a power law, a mathematical relationship where one quantity changes as a power of another. It represents an exquisite optimization, a balance struck by evolution so that large organisms can fuel their vast bodies without burning themselves out from the inside. The efficiency is built into the very architecture of life, in the fractal branching of circulatory and respiratory systems that deliver resources to every cell. Now look up at the galaxies. They too obey scaling laws. The brightness of a galaxy, its luminosity, relates to its mass in a predictable, non-random way. The size of a galaxy cluster connects to the speed at which galaxies move within it. The properties of the dark matter halos that cradle these cosmic structures follow their own set of precise mathematical relationships. The physics here is utterly different: gravity and dark matter versus biochemistry and cellular respiration. Yet the outcome is the same, a universe where complex structures settle into stable states described by clean, elegant mathematics. Why would such different systems speak the same numerical language? The answer lies in the universal drive toward stable, efficient configurations. In biology, scaling laws emerge from the evolutionary pressure to efficiently distribute energy and materials through a three-dimensional body using networks that are, at their core, fractal and space-filling. The organism that masters this efficiency survives. In the cosmos, scaling laws emerge from the gravitational collapse of matter within the invisible scaffolding of dark matter halos. Gravity, acting over billions of years, naturally sculpts systems that balance kinetic energy and gravitational potential, leading to predictable correlations between mass, size, and motion. It is the universe finding its most probable, stable arrangements. This parallel is not a sign that galaxies are alive, but that both living and cosmic systems are complex systems. And complex systems, when left to evolve under a consistent set of rules, whether natural selection or gravitational physics, tend to converge on states of optimal organization. The mathematics becomes a description of that settled state, a signature of a system that has reached a kind of dynamic equilibrium. It is as if reality has a preferred set of blueprints for building stable, enduring structures, and whether you are building with cells or with clusters of galaxies, you end up consulting the same mathematical playbook for efficiency. This deepens the network analogy profoundly. It is not just about similar shapes or similar connections. It is about similar governing principles of organization. The cosmic web and the web of life both whisper the same truth, that from complexity, order emerges, and that order is often beautifully, predictably mathematical. But even the most stable equilibrium requires a counterbalance. For all the intricate pulling of gravity that weaves the cosmic web, there exists a force working in perfect opposition. We call it dark energy, and its discovery revealed a universe not just expanding but accelerating apart. If dark matter is the skeleton giving the cosmos its form, then dark energy is the breath, a vast, gentle exhalation stretching the very fabric of space itself. This is not a force we feel or see, but its effect is written across the cosmos. By observing distant supernova, astronomers made a startling discovery in the late 1990s. The expansion of the universe, which everyone expected to be slowing down due to the collective gravity of all matter, was instead speeding up. Something was pushing galaxies apart with ever-increasing vigor. That something is dark energy, a property of empty space that exerts a kind of repulsive gravity, acting like an anti-gravity force on the grandest scales. It is the dominant energy in the cosmos today, making up about 68% of everything. Now, imagine this force acting upon our cosmic network. Picture the filaments of the web, those great threads connecting galaxy clusters. Dark energy is not breaking these gravitational bonds within a cluster or along a dense filament. Instead, it is stretching the space between the major nodes of the web. The vast voids are growing larger. The distances between separate superclusters are increasing at an accelerating rate. It is as if the canvas upon which the cosmic tapestry is woven is itself being steadily pulled tauter. This introduces a profound dynamic tension, a cosmic rhythm. For billions of years, gravity was the sole sculptor, pulling matter together, condensing clouds into stars, gathering galaxies into clusters, and weaving the web. It was the universe's great inhalation, drawing everything inward. Now, dark energy has taken the lead, becoming the dominant force driving an exhalation, pushing the large-scale structure apart. This is not a destructive process, but a transformative one. It adds a vital, pulsating quality to the cosmic organism analogy. Any living, breathing entity exists in a balance between contraction and expansion, between drawing in resources and releasing energy. Our own breathing is a perfect rhythm of inhalation and exhalation, a cycle essential to life. The cosmos, in its own slow, deep time, may be engaged in a similar cycle. The gravitational inhalation built the complex structure we see today. The dark energy exhalation is now setting the stage for its future evolution, determining the ultimate fate of the network. This dynamic tension is essential. Without gravity's initial pull, no structure would have formed, and the universe would be a thin, featureless fog. Without dark energy's push, the universe might have eventually collapsed back on itself in a great crunch. Instead, we live in the balanced moment between these two titanic forces, in a universe that is both intricately connected and gracefully expanding. This breath gives the cosmic network its current scale and its lonely, beautiful architecture, where islands of light are separated by ever-widening seas of darkness. It reminds us that the cosmos is not a frozen monument, but a living process, inhaling the past and exhaling the future in a cycle measured in billions of years. These deep mathematical parallels between life and cosmos are not just curiosities, they are invitations for a profound conversation. The network perspective we have been exploring opens a door between two seemingly distant realms of science, cosmology and biology. For decades, these fields have operated in separate spheres, one looking outward to the vast and ancient, the other inward to the intricate and immediate. But when both see the world as a web of connections, they suddenly have a common language, Ecologists spend their careers untangling food webs, the delicate networks of who eats whom that determine the health of an entire forest or coral reef. Neuroscientists are painstakingly mapping the connectome, the complete wiring diagram of neural connections in a brain. Sociologists chart the invisible threads of social networks that shape how ideas and behaviors spread through communities. These scientists have developed powerful tools and theories to answer network-specific questions. How does a network withstand shock? Where are its critical bottlenecks? How does information or influence flow through it? And at what point does the entire system undergo a sudden, dramatic change? These are precisely the kinds of questions cosmologists are now asking about the cosmic web. The dialogue can move beyond mere metaphor into a fertile exchange of frameworks. For example, biologists and ecologists deeply understand the concept of a tipping point, that critical threshold where a small change triggers a large, often irreversible shift in the state of a system. A lake can tip from clear to algae choked with a slight increase in nutrients. A forest can transition from carbon sink to carbon source with a rise in temperature. Could similar tipping point dynamics be hidden within the physics of galaxy formation? Perhaps the ignition of the first stars in a primordial cloud represented a cosmic tipping point, permanently altering the chemical and thermal future of that entire filament of the web. Similarly, the study of how behaviors or information spread through social networks, sometimes called network contagion, relies on understanding which nodes are most influential and how connected clusters can amplify a signal. This might offer a new lens for modeling how waves of star formation could propagate along a galactic filament, or how feedback from a supermassive black hole might regulate activity across an entire cluster. This cross-pollination of ideas does not mean galaxies are alive. It means the abstract logic of networks is universal. A biologist's model for predicting the collapse of a fishery might, with its parameters utterly transformed, help a cosmologist simulate the collapse of a gas cloud into a stellar nursery. This interdisciplinary bridge enriches both fields. It gives cosmologists fresh analogies and potential analytical tools borrowed from sciences practiced on more human scales. And in return, it offers biologists a majestic, billion-year-old validation of the network principles they study, written across the heavens. It underscores a beautiful truth that the pursuit of understanding, whether focused on a single cell or a supercluster, is ultimately part of the same great project, deciphering the common language of connection that the universe speaks at every scale. The elegance of the network analogy can feel almost too perfect, a seamless bridge between the cosmic and the living, yet a bridge is not the same as a merging of lands. To truly respect the majesty of both, we must carefully note where the path ends, where the comparison reaches its natural limit. The universe is not a biological organism. It does not breathe with lungs, think with neurons, or strive to pass on its genetic code. The connections we have marveled at are forged by gravity, a force that pulls without intention, and by quantum laws that operate with mathematical necessity, not desire. The filaments of the cosmic web are not conscious highways. They are the aftermath of a gravitational collapse that unfolded over eons, a patient sculpture carved by impersonal physics. The timescales alone are a chasm of difference. A human thought flashes across synapses in milliseconds. A galaxy completes a single rotation over hundreds of millions of years. The metabolism of a star fusing hydrogen into helium is a nuclear process utterly alien to the chemical digestion that fuels a cell. There is no DNA in the void, no blueprint for heredity that guides a galaxy cluster to produce offspring clusters. The universe expands and evolves, but it does not reproduce. To forget this is to risk a subtle but significant error, dressing the cosmos in a suit of metaphors that does not quite fit, a kind of scientific anthropomorphism. We must be vigilant against the temptation to see purpose where there is only process, to see a mind where there is only magnificent mechanism. Yet, this act of defining the boundary is not a dismissal of the analogy. It is, in fact, where its greatest value is refined. By clearly seeing where the comparison breaks, we achieve a sharper focus on what is uniquely, astonishingly cosmic. We isolate the pure laws of gravity and thermodynamics operating on a canvas of spacetime. We appreciate the dark matter scaffold for what it is, a mysterious form of mass that interacts only through gravity and perhaps the weak nuclear force, a substance utterly indifferent to the complex chemistry it makes possible. This clarity also helps us identify what might be genuinely universal, principles that transcend their substrate. The emergence of complex patterns from simple rules, the tendency of matter and energy to self-organize into efficient, networked structures under constraint, the presence of feedback loops that regulate systems, these are the abstract, mathematical echoes that seem to resonate whether the system is made of stars, cells, or silicon. Distinguishing the cosmic from the biological allows both to shine in their own right. It prevents us from diminishing the strange, ancient, and beautifully alien reality of the universe by forcing it into a familiar, earthly box. At the same time, it elevates those shared principles of organization to a new status, suggesting they are deeper features of reality itself, not merely accidents of our particular kind of life. So the network analogy is not a statement of identity, but a tool for inquiry, a lens that brings certain profound similarities into focus while leaving the fundamental differences in stark, instructive relief. And with this clearer view of what the cosmos is and is not, we are finally equipped to ask the most practical question of all: what does this perspective, this network view of reality, actually change for us here and now? The same principles that organize the cosmos are already guiding our most advanced creations. Artificial intelligence, particularly the kind built on neural networks, is a testament to this. These digital minds are not programmed with rigid, step-by-step instructions. Instead, they are designed as vast webs of simple, interconnected nodes, inspired directly by the biological networks in our own brains. They learn by adjusting the strength of connections between these nodes, finding patterns in data, much like a brain strengthens synaptic pathways through experience. This has proven to be a phenomenally powerful way to process information, enabling machines to recognize faces, translate languages, and even compose music. But if biological neural networks offer one blueprint for intelligence, could the cosmic web offer another? The universe's architecture is a network of a different order, one that has been stress-tested for stability over billions of years. Its design is not based on rapid, localized learning, but on the slow, gravitational sculpting of matter into the most efficient possible configuration for distributing influence and sustaining structure across unimaginable voids. This cosmic network possesses a deep hierarchy, from the vast dark matter filaments down to the clusters of galaxies, and further down to the individual stars and planets. It is incredibly resilient, able to absorb the shock of supernova and galactic collisions without collapsing. And it processes information in its own way, with gravity as its signal and the flow of gas and energy as its data. Researchers are beginning to ask if this cosmic blueprint could inspire the next leap in our own technology. Could we design new kinds of artificial neural networks that mimic the cosmic web's hierarchical resilience? Instead of a flat web of connections, imagine a computational architecture with layers of connectivity that mirror the filaments and nodes of the universe, creating systems that are exceptionally robust to failure and efficient at transmitting information across vast digital distances. Some scientists are already using this cross-pollination. They run immense cosmological simulations, which are essentially digital universes governed by the laws of physics. to test theories about network growth, information flow, and system stability. By studying how the cosmic web forms and endures in these virtual labs, they can extract mathematical principles of organization that might be applied to other complex networks, from global telecommunications grids to the next generation of machine learning models. This creates a fascinating and profound feedback loop. We use computers to simulate the universe, and in understanding the universe as a kind of cosmic computer or an ultimate information processing network, we may discover new algorithms that make our own computers smarter and more resilient. It suggests that the quest to understand the cosmos is not a one-way street. The universe is not just an object to be observed, it is a masterclass in systems design. By learning its deepest architectural secrets, we might not only unlock mysteries of dark matter and galactic evolution, but also write the code for artificial intelligences that are more adaptable, more distributed, and more deeply integrated with the complex, interconnected logic of reality itself. The beauty of the cosmic web is not merely a scientific observation, it is a profound human experience. When we see that image of galaxies strung along luminous filaments, something within us stirs, a sense of awe that feels deeper than intellectual understanding. This resonance might be rooted in the very structure of our own minds. We are innate pattern seekers, wired from birth to find faces in clouds, constellations in stars, and stories in random events. Our brains are themselves dense networks of neurons, constantly forming and pruning connections in search of meaning. It is perhaps no surprise, then, that when we look out and see a universe structured as a network, our own internal network recognizes a kindred pattern. We are built to see connections, so a connected cosmos feels intuitively familiar, even beautiful. This instinct goes far beyond modern science. Across cultures and millennia, humanity has used the imagery of webs, trees, and intricate tapestries to describe the nature of existence. In countless mythologies, the world tree connects the heavens, the earth, and the underworld. Ancient spiritual traditions speak of an interconnected web of life, where every action reverberates through the whole. Artists have forever been drawn to mandalas, fractals, and branching forms, capturing a universal aesthetic that seems to speak to a fundamental truth about reality's architecture. This enduring artistic and spiritual impulse suggests that the network concept satisfies a deep human need to see ourselves as part of a meaningful, integrated whole, not as isolated specks in a meaningless void. The cosmic web, as revealed by our telescopes, provides a powerful, empirical echo of this ancient intuition. It offers a narrative where we are not accidental tourists, but threads consciously woven into a grand, evolving tapestry. That feeling of beauty we experience is therefore a complex fusion, a meeting point between the external structure of the cosmos and the internal structure of our perception. It is science confirming a deep-seated poetic truth that connection is not just a physical principle, but perhaps the very source of meaning itself. The maps we have of the cosmic web are magnificent, but they are still sketches compared to the masterpiece we know is out there. To move from recognizing the pattern to truly understanding its mechanics, we need to see it in exquisite, three-dimensional detail. This is the new frontier of cosmology, an era of digital cartography on a scale that was pure fantasy just a generation ago. We are building the telescopes to become cosmic surveyors, to trace every thread and node of this vast living network with a precision that will either confirm our deepest theories or shatter them. Leading this charge are instruments of staggering ambition. On a mountaintop in Arizona, the Dark Energy Spectroscopic Instrument, or DESI, is not a traditional telescope that takes pretty pictures. It is a robotic eye with 5,000 tiny, automated fibers, each one capable of pinpointing a single galaxy. Its sole mission is to measure the redshift, and thus the distance, of tens of millions of galaxies and quasars, building the largest and most detailed three-dimensional map of the universe ever attempted. This map will not just show us where the filaments are, it will let us measure how they are being stretched and pulled by the competing forces of gravity and dark energy across cosmic time. Meanwhile, the Euclid Space Telescope, a European mission now gliding in the silence beyond Earth, takes a complementary approach. From its pristine vantage point, free of our atmosphere's blur, it will image billions of galaxies to measure their subtle distortions. This technique, called weak gravitational lensing, allows Euclid to literally map the invisible, the dark matter scaffolding itself, by seeing how its gravity bends the light from galaxies behind it. It will produce a ghostly image of the universe's true skeleton, and looking to the future, the Square Kilometre Array, a radio telescope being built across 2 continents, will listen for a different signal. It will detect the faint radio whisper of neutral hydrogen gas, the primary fuel of stars, that is believed to stream along the dark matter filaments. This instrument could allow us to see the cosmic web's circulatory system directly, tracing the rivers of raw material that flow into the hungry galaxies at the intersections. Together, these projects aim to answer foundational questions. They will scrutinize the accelerating expansion driven by dark energy, measuring its effect on the growth of the web's structure with razor-sharp accuracy. They will peer back to the epoch of reionization, a cosmic dawn when the first stars and galaxies flickered on, their intense radiation burning away the primordial fog and lighting up the first strands of the network. This data will be the ultimate test for our models. Do the simulations of cosmic evolution, which start with the tiny ripples in the cosmic microwave background and apply the laws of physics, truly reproduce the intricate network we observe? If they match with stunning precision, it will be a monumental triumph for our standard model of cosmology, confirming that gravity, dark matter, and dark energy are indeed the primary architects of reality. But if there is a persistent, subtle mismatch between the predicted web and the observed one, it could be the crack that reveals entirely new physics, perhaps a modification to gravity itself or a new property of dark matter. This observational journey transforms our analogy. The cosmic web as a living network will cease to be a poetic metaphor and become a detailed, quantitative description. We will not just say the universe is structured like a network. We will have its full blueprint, understanding its flows, its tensions, and its history with a clarity that brings this grand architecture into a focus so sharp it feels almost touchable. The data from our telescopes presents us with a quiet philosophical revolution. If the universe truly operates as a vast, self-organizing, resilient network, then our most cherished definitions begin to tremble at their foundations. What, after all, do we mean by life? For centuries, we have defined it by a checklist drawn from our single example, earthly biology. It must metabolize, grow, reproduce, respond to stimuli, and adapt. A bacterium checks these boxes. A galaxy cluster does not. It does not eat. It does not have offspring in any biological sense. By this traditional standard, the cosmos is undeniably inanimate, a beautiful but dead machine. Yet, we now see this machine exhibiting behaviors we once thought exclusive to the living world. It builds intricate, fractal structures. It maintains itself through dynamic feedback loops. It processes information and energy in a constant flow. It evolves over time into states of greater complexity and connection. The machine is humming with a familiar tune. This dissonance forces a profound question. Are we looking at the checklist wrong? Perhaps life is not a binary state, something you either are or are not. Perhaps it is a spectrum, a gradient of complexity and organization. Philosophers of science and astrobiologists are increasingly drawn to this idea. They propose shifting from a chemical definition based on carbon and water to a functional or systemic definition. In this view, life is not about what something is made of, but what it does. It is the property of a complex system that sustains and organizes itself against entropy, that processes information from its environment, and that adapts to maintain its existence. A cell does this, a rainforest does this at a larger scale, and intriguingly, a galaxy, or even a filament of the cosmic web, exhibits echoes of these very processes on a scale so grand we are only learning to see them. This is not to claim the universe is biologically alive as a tree is alive, but to suggest that the principles of self-organization and complex connectivity we call life might be universal principles of physics, manifesting in different ways depending on scale and substrate. This radically expands the canvas on which we might search for other minds in the darkness. If intelligence is an emergent property of sufficiently complex, interconnected networks, then we must look beyond green planets and oxygen atmospheres. The signature of a cosmic intelligence would not be a radio message in a language we understand. It might be the very architecture of a galaxy, optimized in some way we cannot yet perceive. It could be a pattern in the dark matter distribution, a stability in a star cluster that defies simple gravitational models, or an anomalous flow of energy along a filament that suggests not just physics, but a physics being manipulated. The search for extraterrestrial intelligence becomes, in part, a search for cosmic anomalies that look like engineering. This perspective does not diminish the wonder of biological life on Earth. It places our own consciousness within a much broader narrative. We are one specific, beautiful manifestation of a cosmic tendency toward connection and complexity. Our brains are a local, rapid form of a network that the universe builds in a slower, vaster form across the light years. This realization invites a deeper humility and a more expansive curiosity. We are not just looking for life as we know it, we are learning to recognize life as the universe might build it, in forms stranger and more magnificent than we ever dreamed. The universe does not build its structures in isolation. Within a forest, the fate of a towering oak is inseparable from the fungi entwined in its roots, the insects that pollinate its flowers, and the birds that disperse its seeds. They evolve together, each shaping the other's destiny in a continuous, reciprocal dance. This principle of symbiotic co-evolution, so fundamental to life on Earth, finds a stunning parallel in the grand architecture of the cosmos. The components of the universe are not independent actors on a passive stage. They are partners in a tightly coupled, billion-year-long ballet of mutual influence. Consider the most fundamental partnership, the one between dark matter and luminous matter. A galaxy does not simply form inside a pre-existing dark matter halo like a pearl in a static shell. Instead, they grow together in a constant gravitational dialogue. The dark matter halo provides the deep gravitational well that draws in the ordinary gas. As that gas collapses, cools, and ignites into stars, the energy released from those stars, and later from supernova and black holes, begins to push back. This feedback can heat the surrounding gas or even blast it away, which in turn alters how the dark matter itself is distributed, subtly reshaping the gravitational landscape that started it all. It is a co-evolutionary process where the growth of one directly informs the growth of the other. This symbiotic relationship extends to the most extreme objects in the universe. At the heart of nearly every large galaxy sits a supermassive black hole, a gravitational monster with the mass of millions or even billions of suns. For decades, these black holes were seen as cosmic drains, mere endpoints. Now we understand they are dynamic regulators, engaged in an intimate feedback loop with their host galaxy. When the galaxy feeds the black hole, allowing gas to spiral in, the black hole does not consume quietly. The infalling matter releases a torrent of energy, often in the form of searing radiation and colossal jets of particles. This outpouring of energy acts like a cosmic thermostat, heating the galactic gas so violently that it prevents further star formation, effectively putting a limit on the galaxy's growth. The galaxy, in turn, controls the black hole's food supply. This mutual regulation means the black hole and the galaxy evolve together, their sizes and activities mysteriously correlated across the universe, as if bound by an invisible treaty. Even the most enigmatic force, dark energy, enters this dance of interdependence, though on a vastly different timescale. For the first several billion years after the Big Bang, gravity was the undisputed sculptor, pulling matter together to weave the cosmic web. Dark energy existed, but its repulsive effect was negligible, drowned out by the density of the younger, smaller universe. As expansion diluted matter, dark energy's constant presence began to dominate. Its influence became significant only as the universe aged, changing the very rules of the game. It began to stretch the space between the great filaments, slowing the growth of new structure and setting the future tempo for cosmic evolution. The development of the web, therefore, is not dictated by gravity alone, but by the evolving relationship between gravity's pull and dark energy's push. This interconnected evolution, where the state of one cosmic component directly influences the development of another, mirrors the deep interdependence of an ecosystem. In a coral reef, the health of the coral depends on the algae living within it, which in turn depends on the fish that graze around it, which depend on the larger predators that maintain balance. Change one element and the entire system shifts. The cosmos operates on a similar, albeit physical, principle. The dark matter, the galaxies, the black holes, and the dark energy are not isolated pieces. They are parts of an integrated cosmic ecosystem, evolving in concert according to the unbreakable laws of physics. This paints a picture of a universe far more integrated and dynamically intertwined than a simple collection of objects, revealing a symphony of mutual influence where every player, from the smallest particle to the most immense force, helps compose the story of the whole. Every magnificent structure begins with a single, unassuming seed. For the cosmic web, that seed was not a physical object, but a whisper in the void, a quantum fluctuation imprinted on reality in the first fleeting moments of time. To understand the unique pattern of filaments and voids we call home, we must travel back to a time before atoms, before light, before anything we would recognize as substance. In that searing, unimaginable density just after the Big Bang, the universe was not perfectly smooth. Thanks to the inherent uncertainty of quantum physics, tiny ripples in energy density flickered in and out of existence. These were random, probabilistic hiccups in the fabric of spacetime itself. Then, in a fraction of a second, a process called inflation occurred. A brief but stupendous stretching of space that magnified those microscopic quantum ripples to cosmic proportions. Think of it like taking a microscopic, random wrinkle on the surface of a balloon and then inflating the balloon to the size of the Earth. The wrinkle becomes a continent-spanning mountain range. In the same way, those infinitesimal quantum fluctuations were stretched into the grand, landscape-shaping variations in density that would define the entire future of the cosmos. This is the universe's foundational blueprint, its cosmic DNA. Just as the genetic code in a single cell contains the instructions that will guide the development of a unique, complex organism, this pattern of denser and less dense regions contain the complete instructions for where galaxy clusters would blossom and where vast, empty voids would grow. It was a unique seed. Had the quantum dice rolled differently in that first instant, producing a slightly different pattern of ripples, our cosmic web would look entirely different today, with filaments in other places and voids elsewhere. The specific map we observe is the result of one particular random draw from the quantum lottery, subsequently developed by the unwavering laws of physics. This idea transforms our view of cosmic history. The development of the web was not random from start to finish. It was a profoundly deterministic process acting on a random starting point. Gravity, dark matter, and the laws of hydrodynamics are the universal, rule-based machinery, like the cellular processes that read DNA. The initial quantum fluctuations are the unique, random data fed into that machinery. Once the seed was set, the outcome was, in principle, calculable. The universe had no choice but to unfold exactly as it has, weaving those primordial wrinkles into the glittering network we now chart. This resolves a deep tension in how we see the cosmos. The result appears finely tuned, intricate, almost designed. Yet its origin was fundamentally random, and its construction was entirely mechanical. There is no contradiction. A complex, beautiful, and unique snowflake forms from the deterministic laws of crystal growth, acting on the random conditions of temperature and humidity as it falls. Our universe is the ultimate snowflake, crystallized from a quantum seed and grown by gravity over billions of years. This perspective places us within a cosmic story that is both inevitable and singular, a narrative written by chance and then executed with perfect, lawful precision. Our universe's magnificent network may not be the only performance. Some of the most profound cosmological theories suggest it could be a single act in an endless cosmic play. This is the idea of eternal return, the possibility that the universe or reality itself undergoes infinite cycles of birth, expansion, and renewal. One such vision is conformal cyclic cosmology, proposed by physicist Roger Penrose. It paints a picture where the far, far future of our universe, stretched and cooled into a state of near-nothingness, becomes mathematically identical to the hot, dense singularity of a new Big Bang. In this model, the end of one eon seamlessly becomes the beginning of the next, with the information and structure of the old cosmos somehow imprinting itself on the new. Another idea emerges from string theory, where our universe is a three-dimensional brain floating in a higher dimensional space. In this multiverse, brains could collide, each collision sparking a new hot Big Bang and a new cosmic network, with the brains then drifting apart only to collide again in an eternal, rhythmic dance. If either of these speculative pictures holds a grain of truth, then the living network we inhabit is not a one-time event. It is a recurring pattern, a template that reality returns to again and again. The filaments form, galaxies ignite, stars forge elements, and conscious observers arise to witness it, only for the entire tapestry to eventually dissolve back into a formless state, ready to be rewoven in the next cycle. This extends the network analogy across a dimension we can scarcely comprehend, time itself. Instead of a single, static web, we are looking at a temporal network, a chain of universes linked in sequence, each one a node in a timeline of cosmic epochs. The principles we have observed, connection, growth, feedback, and self-organization, would not be fleeting accidents of our particular cosmic configuration. They would be eternal features, the unchanging rules of a game that has been played an infinite number of times and will be played an infinite number more. Our quest to understand the cosmic web then becomes something even more profound. We are not just deciphering the architecture of our home, we are glimpsing the timeless, repeating blueprint of all possible homes. It suggests that the drive toward complexity and consciousness is not a brief spark in a cold void, but a fundamental, recurring theme in the endless story of existence. While these ideas remain at the farthest edge of theoretical physics, they complete a philosophical circle. They offer a vision where the network is not just the shape of space, but the very shape of time, an eternal rhythm of connection and transformation that makes our fleeting, beautiful moment within it feel both infinitesimally small and infinitely precious. Our own origin story is written in the language of stellar furnaces and gravitational tides. The calcium in your bones, the iron in your blood, the oxygen you breathe, these were not present at the beginning. They were forged in the hearts of massive stars that lived and died long before our sun ignited. In their final cataclysmic supernova explosions, they were cast out into the void, enriching the cosmic clouds that would one day collapse into new solar systems. The very matter that constitutes you and me was once part of that silent, flowing traffic along the dark matter filaments, eventually delivered to a particular spiral arm of a particular galaxy to coalesce into a planet, an ocean, and a living, thinking being. We are not just inhabitants of the cosmic web, we are its literal substance rearranged and animated, and within us the network finds its most intricate known reflection. The human brain, with its roughly 86 billion neurons connected by trillions of synapses, is the most complex natural network we have ever encountered. Its dense, shimmering web of connections is where experience, memory, and consciousness arise. This means the universe, having woven itself into a vast, physical network of galaxies, has also produced, on at least one small planet, a conscious, neurological network capable of looking back out and recognizing the pattern. This is the profound symmetry at the heart of our exploration. When an astronomer points a telescope at a distant filament of the cosmic web, a cascade of photons that has traveled for billions of years strikes a detector. That signal is converted into electrical impulses that travel along the neural pathways of the astronomer's brain, firing across synapses, lighting up regions associated with pattern recognition, awe, and understanding. In that moment, the universe is not being observed by something separate from itself. The network is observing the network. A structure born from gravity is using a structure born from biology to comprehend its own existence. The late astronomer Carl Sagan gave this idea its most beautiful and enduring form, noting that we are a way for the cosmos to know itself. This is not merely poetic metaphor. It is a scientific and philosophical truth grounded in the shared ancestry of matter and the shared architecture of connection. Our burning curiosity about where we came from, our drive to map the filaments and measure the redshift, this is not an external hobby. It is the cosmic web's own activity. It is a node within the network, a specific point where stardust has become self-aware, attempting to trace the threads that bind it back to the source. Every question we ask about the universe's structure is, in essence, the universe asking a question about itself. This realization closes the loop on our entire journey. It means the search for understanding is not a lonely human pursuit in an indifferent void. It is a participatory act, a vital function of the living, breathing system we are part of. We are the universe contemplating its own magnificent, entangled design. This intimate connection to the cosmic web is not just a scientific insight, it is an invitation to a new way of being in the world. Recognizing ourselves as threads in this grand tapestry immediately cultivates a profound cosmic humility. Our personal concerns, our societal conflicts, and even the entire span of human history are events occurring within a single, conscious node of a network that has been evolving for nearly 14 billion years. This perspective does not diminish our lives, but frames them within a story of such staggering scale and beauty that it can quiet the noise of our everyday anxieties, offering a grounding sense of place. We are not the center of the universe, but we are a meaningful part of its ongoing narrative, and that realization carries a quiet, powerful responsibility. This worldview challenges the deep-seated narrative of human separation, the idea that we are isolated observers standing apart from a dead, mechanical nature. The network view erases that line. We are nature thinking. The same atoms cycling through stars now cycle through our cells. The same principles of connection that structure galaxies also structure our societies and our minds. This understanding fosters a sense of kinship that extends beyond our species to encompass the living planet and the dynamic cosmos itself. From this kinship emerges a potential ethical framework, sometimes called cosmocentric ethics. If our well-being is inextricably tied to the health of the larger systems that produced and sustain us, then actions that harm those systems are ultimately acts of self-harm. Caring for Earth's biosphere, its climate, and its intricate ecosystems is no longer just an environmental cause. It becomes a cosmic imperative. It is the act of a conscious node tending to its immediate local network, ensuring the conditions that allowed it to awaken are preserved for future nodes of awareness. This stewardship is born not from fear or duty alone, but from a deep recognition of unity. Furthermore, this cosmic perspective offers a powerful antidote to the fragmentation and conflict that so often define our age. When we look up and understand that every human being, every creature, and every landscape shares this common cosmic ancestry and participates in this universal architecture, petty divisions begin to pale against the backdrop of our shared story. An awe-based perspective, rooted in the scientific reality of our connection, can become a unifying force. It provides a common ground for wonder that transcends cultural, political, and religious boundaries, reminding us that we are all, quite literally, made of star stuff and shaped by the same cosmic forces, passengers together on a pale blue dot woven into an infinite web of light. This is perhaps the most practical gift of the network analogy. It gives us a story that is both true and beautiful, a narrative that can inspire not only curiosity about the heavens, but also greater compassion, responsibility, and a sense of shared destiny here on our fragile, luminous node in the vast cosmic net. The living network analogy is a powerful lens, but it is not a final answer. It opens a new frontier of questions, perhaps even more profound than the ones it resolves. If the cosmos truly operates like a vast, interconnected system, then we must ask, what exactly is flowing through these connections? Are the filaments merely gravitational highways for matter, or could they also be conduits for something more abstract, like information or quantum influence? The nature of the link itself is the deepest mystery. Gravity is our primary language for describing these bonds, but some theorists wonder if it is the only dialect being spoken. Could there be an informational layer, a kind of cosmic code, that underlies the gravitational geometry we observe? This quest drives researchers to search for mathematical isomorphisms, identical forms, between the equations that describe biological networks and those that govern the cosmos. Imagine finding that the same formula that predicts the spread of a neural impulse also describes how a density wave moves along a galactic filament. Such a discovery would not be a vague metaphor, but a concrete mathematical bridge between the living and the cosmic, hinting at a universal logic of organization. Meanwhile, observers are pushing our maps to new extremes of precision. Projects like the Dark Energy Spectroscopic Instrument are not just cataloging galaxies. They are measuring the subtle tug of war between dark energy and gravity with such detail that we might see if the web's growth matches our predictions down to the finest thread. Any deviation, any tiny kink in a filament that shouldn't be there, could be a clue to entirely new physics, and hovering over all of this is the quantum question. How does the spooky, interconnected realm of the very small translate into the grand, classical architecture of the cosmic web? Does quantum entanglement play any role in the large-scale cohesion of the universe, or is its influence washed out by the time galaxies form? This is where the most speculative and exciting theoretical work lies, at the bleeding edge of quantum gravity and information theory. The key thing to remember is that this is not settled history. It is a vibrant, open field of research, a living conversation among cosmologists, astrophysicists, and even biologists and network scientists. Every new data point from a telescope, every new simulation on a supercomputer, adds another thread to our understanding. The mystery is ongoing, and that is the most thrilling part. We are not just learning what the cosmic tapestry looks like, we are actively unraveling how it was woven and by what hand. A metaphor is a lens, not a photograph. When we describe the cosmos as a living, breathing network, We are not making a literal claim that galaxies possess biological functions. We are employing a powerful cognitive tool, a framework that allows the human mind to grasp patterns too vast or strange for direct intuition. Throughout history, the dominant metaphors for the universe have shaped the very trajectory of science. For centuries, following the insights of thinkers like Newton and Descartes, the cosmos was envisioned as a magnificent clockwork, a perfect machine governed by immutable laws. This metaphor was spectacularly fruitful. It led to precise predictions of planetary motion, the unification of heaven and earth under a single mechanics, and the technological revolutions of the industrial age. The machine universe was predictable, deterministic, and beautifully orderly. But like any lens, it brought certain features into sharp focus while leaving others blurred. It struggled to accommodate concepts like chaos, emergence, and the inherent uncertainty revealed by quantum physics. The living network metaphor emerging today is a different kind of lens. It does not replace the laws of physics, but it offers a new way to organize our understanding of their consequences. Instead of seeing isolated cogs in a gearbox, it invites us to see relationships, flows, and the self-organizing patterns that arise from simple rules. This shift in perspective directly shapes the questions scientists ask. A researcher thinking in machine terms might ask, what is the specific force causing this motion? A researcher thinking in network terms might ask, how does information or influence propagate through this system, and where are the critical points of connection? This new framework guides the construction of our models. The most advanced simulations of cosmic evolution are no longer just calculating the trajectories of billions of particles. They are analyzing the emergent web for small world properties, for resilience to shock, for the efficiency of its informational pathways. They are treating the cosmos as a complex system, a category that includes economies, ecosystems, and the internet. Even our technology begins to mirror this conceptual shift. We build artificial neural networks inspired by brains, and we look to the cosmic web's architecture for clues to design more resilient data networks. The power of a guiding metaphor is that it opens doors we did not previously know were there. It allows us to borrow analytical tools from seemingly unrelated fields, like ecology or neuroscience, and apply them to the cosmos, asking if the same principles of stability and growth apply. Yet with this power comes a vital responsibility, the need for mindful awareness. We must remember that the map is not the territory. The network metaphor is an incredibly useful map, but it is not the universe itself. The moment we confuse the metaphor for literal truth, we risk forcing observations to fit a pleasing story, or overlooking phenomena that do not conform to our chosen framework. The history of science is littered with the remnants of metaphors that outlived their usefulness, from celestial spheres to the luminiferous ether. Their value was not in being permanently correct, but in providing a temporary scaffold for understanding, a structure to be climbed and then dismantled once a clearer view was achieved. So we hold this network view with both hands, appreciating its illuminating power while keeping our eyes firmly on the empirical evidence. The ultimate test is not how elegant or inspiring the metaphor feels, but how well it helps our equations predict what we see through the telescope, and how effectively it guides us to the next, deeper layer of cosmic mystery. Take a deep breath and for a moment close your eyes. Begin by feeling the ground beneath you, the air in your lungs. Now, in your mind's eye, let your awareness expand upward, through the ceiling, through the atmosphere, until you see the whole of our planet, a swirling blue marble hanging in the black. See the thin, glowing film of its biosphere, that delicate network of all life, cradling the entire human story. Now pull back further. Watch the sun shrink to a bright point, the planets becoming mere specks orbiting it. Our solar system is now a tiny, intricate clockwork lost in the void. Keep going. the Sun becomes one star among hundreds of billions, swirling in the great spiral arms of the Milky Way galaxy. See that majestic disk of light, its core glowing softly, and now pull back even more. See our galaxy not as an island, but as one member of a small, local family, the local group, a gentle gravitational gathering. And this group is not adrift. It is moving, falling along an immense, invisible river of gravity. You are now seeing the Laniakea supercluster, a continent of galaxies 100,000 times larger than the Milky Way, a brilliant, tangled filament in the darkness. And this filament, this strand of light, is just one thread among countless others in the cosmic web, a single stitch in a tapestry larger than imagination can hold. Pause here in that silent, breathtaking scale, then reverse the journey. Zoom back in along that filament into Laniakea, into the local group, into the spiral arm of the Milky Way, past the Sun, through the atmosphere of Earth, right back into this room, into your own awareness. You have carried that entire architecture back with you. This is not a fantasy. It is the scientifically accurate map of your cosmic address. You are here, in this moment, conscious and alive, while simultaneously being a physical part of that galaxy, that filament, that web. The calcium signaling in your neurons and the iron in your blood are elements forged in that web's stellar furnaces, delivered along its filaments. This visualization makes an abstract truth tangible. You do not live in a universe. You are a universe, a localized expression of its matter, energy, and connection, now awake and looking back out at the whole from which it came. That feeling of awe is the network recognizing itself. So we arrive at a new story, one woven from every thread we have followed. It is a story where the cold, empty arena of classical cosmology transforms into something far more dynamic and intimate. The universe is no longer a stage upon which matter passively performs, but a grand, self-organizing process, a single unfolding event that is both the performer and the performance. In this narrative, the glittering filaments of the cosmic web are not just structures, they are the visible expression of a deep, underlying drive toward connection. The fractal patterns in river deltas and galaxy clusters are not coincidences, but signatures of a universal blueprint for building complexity. The dark matter scaffolding is the hidden framework that makes this luminous tapestry possible, while the quantum hints of entanglement suggest that the very fabric of space may be knitted together from threads of information. And the evolutionary narrative, from the first stars to conscious minds, reveals a cosmos that learns and adapts over deep time, not through intention, but through the inevitable consequences of simple rules played out on a grand scale. This synthesis bridges the greatest divides we have known. It gently blurs the line between the living and the non-living, not by claiming rocks are conscious, but by showing that the principles of organization we see in a forest or a brain are echoes of the same principles that structure galaxies. It integrates mind and matter not as separate substances, but as different expressions of the same interconnected system, where consciousness emerges as a property of complex networks, whether neural or cosmic. It even suggests a potential bridge between the quantum and the cosmic, where the spooky links between particles might be the fundamental stitches from which the tapestry of spacetime is woven. This new story does not provide all the answers. In fact, it generates as many questions as it resolves, but its power lies not in finality, but in context. It offers a framework that is richer, more integrated, and more meaningful than the old picture of a lonely universe of isolated objects. Our place within it is utterly transformed. We are no longer accidental tourists marooned on a random rock in a meaningless void. We are participants. We are nodes within the network, formed from its substance, animated by its flows, and gifted with the capacity to perceive the very pattern we are part of. Our cosmic address shifts from a set of random coordinates to a location in a living story. We are here, at this moment in the narrative, where the universe has become complex enough to look back upon itself with wonder. This transforms the act of inquiry itself. Every question we ask about the cosmos, from the nature of dark energy to the origin of life, is no longer an external interrogation. It is the network seeking to understand its own nature. It is the story, through us, attempting to read its own pages. And that changes everything, for it means our search for meaning is not a hopeless cry into silence, but a natural, perhaps even inevitable, chapter in the great unfolding of a connected reality. This journey through the cosmic web leads us to a single, breathtaking realization. The universe appears structured like a living network, not because it breathes or thinks as we do, but because the deepest principles of reality itself seem to favor connection, complexity, and self-organization. These are not merely biological ideas, they are universal blueprints. From the spooky quantum links between particles to the gravitational threads binding superclusters, reality constructs itself through relationships. It builds intricate, resilient patterns that emerge naturally from simple rules, whether those rules govern the firing of neurons or the collapse of galactic gas clouds. This is the profound thread we have followed, a common logic whispering from the fractal branch of a tree to the filament of a galaxy. It is a logic of networks, a preference for woven order over scattered chaos. This perspective does something remarkable. It builds bridges. It allows a cosmologist to speak the same mathematical language as an ecologist studying a forest food web. It lets a neuroscientist and a physicist find common ground in the abstract study of how information flows through a system. By seeing the cosmos as a network, we dissolve the artificial walls between disciplines, revealing a unified quest to understand how complexity arises from simplicity. This unification does not diminish the mystery, it deepens our wonder. The cosmos is re-enchanted not with magic but with a more magnificent truth, its inherent, integrated beauty. We are not looking at a cold, dead machine, but at a dynamic, evolving process that shares the core organizational principles of everything we call alive. This brings us back to the timeless words of Carl Sagan. We are a way for the cosmos to know itself. Our contemplation of the great cosmic network, our mapping of its filaments and our questioning of its origins is the universe performing its most elegant act, self-reflection. In seeking to understand this vast, connected tapestry, we are fulfilling our role within it. We are the network becoming conscious of its own design. If this vision of a deeply connected cosmos has shifted your perspective, we would love to hear how. Share your thoughts in the comments below about what this network view means to you. For more journeys to the edges of understanding, be sure to subscribe. Until next time, keep looking up with wonder and carry this truth with you. You are not just a passive observer in the universe. The universe, in all its networked glory, is actively expressing itself within